Hi, my name is Dewan Hasan. I'm a final year student in ATU pursuing a degree in software and electronic engineering. In this video, I will be discussing about my final year project, which is called ZapZapGo. This project explores a smarter and more convenient way to charge electric vehicles using wireless technology. Plug-in charging works fine, but it can be inconvenient in real-world situations. For example, when a bus is stopped at a bus stop picking up passengers, or when someone is parked at a coffee shop for a quick coffee, wireless charging could quietly top up the battery in the background without the need for cables. As you can see from the architecture diagram, the ESP32 microcontroller acts as the brain of the system. The robocar has a receiving coil underneath, which aligns with the transmitting coil at the charging station. When it parks over the station, wireless charging kicks in through inductive coupling. The ESP32 continuously reads voltage and current data from the INA219 sensor, displays the battery status on an OLED screen, and publishes this live data to the cloud using HiveMQ, which is a secure MQTT broker. On the other hand, the full stack React website subscribed to the MQTT broker. It displays real-time charging information, stores session data in MongoDB, and even calculates charging session costs in the website. So there's full two-way communication between the Robocar and the website through cloud. This is the Robocar setup. As you can see in the OLED screen, it shows the battery status. We have the receiving coil down here in the Robocar setup, and that's the transmitting coil that will generate power. So once we align both the coils, you'll be able to see that the OLED screen is changed to charging and it's blinking. So in the live session, as you can see, it asks the Robocar to be aligned to the charging pad, and it shows the battery status. So once we align the Robocar receiving coil with the transmitting coil, as we can see, it shows the current that it's receiving, and you can see the charging time here as well. 40 seconds enough, so we'll stop the session now. I'm moving the Robocar from the charging pad. As you can see, the timer has stopped, and it also shows the new battery percentage. Now we'll stop the session. Here we can see the charging time, the amount due with the discount applied, and you will be able to see the graph as well of the charging session. As you can see here, it shows the graph of the full time of the charging session and the current that it received over time. So as you can see, the peak current it received was 1.27 amps, and after removing the Robocar from the charging pad, you can see the charging dropped because it was receiving no charge at that point. So this graph gives you an overview of the charging session. Now we proceed to the payment. We can choose to pay our payment type. I'll choose MasterCard. I'll pay now. Once the payment is done, you can go back to the dashboard, and over here you can view your past sessions. As you can see, this is the latest session that we did right now. Now if you go back to the home page, another feature we have in the web interface is that you can search for a nearby charging station by clicking this button. As you can see, this is our location, and it will show us our nearby EV charging stations as well. I hope this gave you a clear look into what ZapZapGo is all about. Thank you for your time.